So we're going to talk about radians, and this will just be like a complete intro. So radian measure is just another way to describe angle measure. So far, we've talked about degrees. And I really want you to think about this as the new hotness for trig, okay? Like you are switching now to radian measure. It is not going to go away, and we're basically going to use it from here on out once it gets introduced to you. So why do we even care about radian measure? What does it allow us to do that degrees don't? Well, it allows us to treat trig functions as functions with real numbers as the domain. So it's a little bit stronger of a way to think of trig functions. Now radians are like have a degree equivalent, but just the way that we think about radians is just, like I said, it's just a slightly stronger way to think of it than just regular old degrees. And okay, so I'm going to show you the formal mathematical definition of a radian, which is a little complicated. You might want to pause the video just to read this, although I'll read it alongside you. So a radian is an angle. So okay, the way we define a radian. So an angle with its vertex in the center of a circle, and then the intercepts on the arc, or you can think of it as the edge of the circle, equal in length to the radius of the circle, has a measure of 1 radian. Okay, so this is a pretty technical definition, and I think a lot of people don't really think of radians this way, but I do want to kind of get you a little more familiar with it. I will say most people think of radians just kind of as an alternative to degrees when they first learn it, but an alternative way to think about this, just to talk a little bit more about the technical aspect of this. So if theta is an angle made in the center of a circle of radius r, and then theta intercepts an arc of the length s, then we'd say that the radian measure of theta is s over r. So this is like another way that we could kind of think about working with radians, is that they do have a relationship to a circle. This will start to make more sense as we continue to talk about things. So if you're like, it doesn't totally make sense, just kind of note this for now. Write this down as like your alternative definition to a radian, and just keep that in mind. So just to kind of visually show you what this is getting at. So I've got this length here. This is my radius, of course. And then let's say that this measure here, pretend that this is 2r. So remember that ratio s over r. I would take 2r over r, and that would give me 2 radians. So this is how we kind of arrive to that. So just giving you a little bit of a visual. Or if I want to do this again, so let's change this up a little bit. Let's say I've got this arc measure here. I've got 1/2 r over r. Again, the r's will cancel out, so this would just be equal to half a radian. So that's kind of the idea behind this. Now, one thing I want to address, are radians, is it like a unit of measure, like feet or meters? No, it is not a unit of measurement. Okay, so don't think of it like that. This ratio, this s over r number we were just talking about, it's just a pure number. Okay, so I want to talk about the formula for the distance around a circle, and I want to figure out how do radians and degrees compare. How can we kind of think between the two? So the general formula for the distance around a circle, so that is like geometry, so that's a circumference, right? So c equals 2 pi r. Okay, so here's the deal. I want to think about this formula a little bit deeper. So what this formula really shows is that r can be measured 2 times around the circle. That's literally what it's getting at, right? 2 pi times r means r can be measured 2 pi times around the circle. So this is important because remember that we said that 360 degrees is the number of degrees around the circle, but now we've also said that 2 pi radians, what we're really getting at here is that 2 pi radians is the number of radians around the circle. So we have this equivalence here. 360 degrees is going to be equal to 2 pi radians. And okay, so if 360 degrees is equal to 2 pi radians, then what is pi radians? What would pi radians be equal to in degrees? Okay, so you're probably thinking, just divide both sides by 2, right, to get to pi, and I would get 180 degrees is equal to pi radians. So we're seeing some equivalencies here. We're seeing a relationship. Now, I will give you a little secret here. This part right here, 180 degrees equals pi radians, this is really what I think of when I am converting between degrees and radians. There is also a general conversion formula. So 1 degree is equal to pi over 180 radians, or 1 radian is equal to 180 degrees over pi. Personally, I don't like thinking about it like this because I feel like this is too much to remember and I will forget. So I prefer to really think in terms of this, but I will say if you like having like a conversion formula, you can also think of it this way. I'm going to show you how to use dimensional analysis though to convert, just to minimize the number of things that you have to remember. Okay, so naturally now we're going to convert from degrees to radians and vice versa. So I'm going to kind of walk you through this. So remember, that general conversion was this. You can technically use this formula, but I really prefer just thinking about this. This is what I can remember the most, the easiest. Okay, so here's how I'm going to set this up. I know this. So what I want to do is I want to take that 35 degrees and I want to multiply it by the pieces of this. And I want to set this up in such a way to ensure that the degrees will cancel out. That's dimensional analysis. That's what it is, right? So if I want this degree up here to cancel out, where does this, so if I'm plugging both parts of this in, where should the degrees go? Should they go on top or on bottom? You want the 180 to go in the bottom because that will allow your degrees to cancel out, and that means that the pi radians goes on top. So let me show you what this looks like. I'm left with pi over 180 radians. So I can set it up like this, or if you want to put the radians up here, it doesn't matter. I'll do it both ways. You'll see a couple different ways you can think about this. Okay, so I want you just to notice how I've set this up. I literally use this like conversion formula, right? I put all the pieces into this, and now with how I've set this up, my degrees cancel out. And so now if I multiply this together, I get 35 over 180 times pi radians. So here is my radians. I can simplify that fraction to 7 pi over 36 radians, or I can multiply this together to get 0.61 radians. Okay, so I think a lot of times, like a lot of homework software, if you have an easy fraction, it probably will prefer the fraction. You generally want to leave in terms of a fraction if it's easy. It's not always easy. I'll show you an example where it's not easy. But in this case, I would say this is like a fraction you can easily convert to, so we want that, okay? But there is also the decimal equivalent, of course. Okay, so this is everything that goes into that. So let's do another one, and I'll kind of walk you through it. So now I want to convert negative 175 degrees to radians. Okay, so remember, pi radians is equal to 180 degrees. So what I want to do is I want to set this up in such a way so that I use both parts of this equivalency, and I want to set it up so that my degrees cancel out. So maybe pause here and set up what you think it should be, and then hit play when you think you've got it. Okay, so once again, my degrees are up here, so when I set this up, I want degrees in the bottom here and then pi radians on top. So I can see, once again, my degrees are going to cancel out, right? And now I can just finish this. This becomes negative 175 pi over 180 radians. So that's the unit that I'm left with. So I can either think of this as the fraction, which I would say is the stronger thing to use in this case, right, as a fraction, but here's also the decimal equivalent. So if I were putting this into homework software, I would probably want to leave it like this because this is a more exact answer versus having to round, if that makes sense. Okay, so now this last one, 27.8 degrees. I want you to try this one entirely on your own. I will tell you, like, this is already a decimal, right? So you can't get a nice fraction. So you will get a decimal answer. Hit play when you're ready. Okay, so I'm going back to my pi radians is 180 degrees. So I set this up, 27.8 degrees times pi radians over 180. So then I know my degrees will cancel out. So I'm left with this calculation. So 27.8 pi over 180. This is not a nice looking fraction, right? Because it has a decimal in it. So I can just go ahead and write this 0.4852 radians. I think a lot of times you'll be told what to round to because unless it tells you specifically to use significant figures. But in this case, I just rounded it as you see here. Okay, so now I want to go the other direction, radians to degrees. Okay, so I've got 7 over 4 pi. So remember, pi radians is 180 degrees. So when I set this up, I'm going to give you a little hint here to help you. These are radians. Force yourself to write the word radian so that you can more easily set up the conversion. So now I'm still using this piece here, but now I want to set this up so that my radians cancel out. So if my radians are here on top, what do I want to go in the bottom of this conversion factor or rate or whatever? I want the radians to go in bottom here. So I want pi radians to go on the bottom and 180 degrees to go on top. So there you go. Now notice the radians drop out, but also what else drops out? The pi, right? So the pi part actually drops out. So then I'm just left with having to do 7 times 180 over 4. So that I can multiply together and I get 315 degrees. Okay, so let me walk you through this next one. So again, we'll try this one a little bit together. So again, we're using this pi radians is 180 degrees. So I want you to set this up, negative 2 pi over 3. Force yourself to write rad or radians, and then set up how you think the conversions should be. Remember, radians needs to cancel out. Hit play when you're ready. Okay, so if I do that, I have 180 degrees over pi radians. And so then I know that both the pi's and the radians are going to drop out. So maybe you want to just write out what we're left with and see if you can get to the final answer. You can hit play when you're ready. So I'm left with negative 2 times 180 degrees divided by 3. So this will come out to negative 120 degrees. Okay, so last one, 7. It's not 7 pi, just 7 radians. You try. No, really, I do want you to try this. So pause here if you haven't been pausing. Hit play when you think you've got it. Okay, so I've got pi radians equals 180. So remember, this stands for 7 radians. So I want the radians to cancel out. So I've got 180 degrees over pi radians so that my radians will drop out. Now, in this case, since this does not have a pi, the pi will not drop out. So we just have to deal with it. So what I'm left with is 7 times 180 degrees over pi, and so that's going to equal 401.07 degrees. All right, so let's keep going with this. So if no unit of measure is given, what do you do in that case? So if that happens, you just want to assume that it's radians, not degrees. So you're not told if it's radians or degrees, just assume it's radians. So this is how important radians is. We just default to it if we've been told nothing. Okay, so what I want to do next is I want to now just, we've talked a bunch about like some common angle measures, and I want to write the radian equivalent to them. So let's start with the really main ones here. So we've talked about 0 degrees. 0 degrees is equal to 0 radians. 30 degrees, so I'll just tell you, is equal to pi over 6 radians. 45 degrees is equal to pi over 4 radians. 60 degrees is equal to pi over 3 radians. And 90 degrees is equal to pi over 2 radians. Okay, so what I want to do is I want to actually fill in this entire like reference chart, right? Because we know that this goes up to 360 degrees. And we have talked a whole bunch about reference angles for here. So I want to actually fill in kind of all the references around the circle. So continuing on, going to the next little arc here, or point, 120 degrees is equal to 2 pi over 3. 135 degrees is 3 pi over 4. 150 degrees is equal to 5 pi over 6. 180 degrees is equal to pi. And so if you want to pause and fill that in, go for it. And then we have the rest of the chart, so everything else. So I'll go ahead and just read around as you're copying down. So 210 degrees is equal to 7 pi over 6. 225 degrees is equal to 5 pi over 4. 240 degrees is equal to 4 pi over 3. 270 degrees is equal to 3 pi over 2. 300 degrees is equal to 5 pi over 3. 315 degrees is equal to 7 pi over 4. 330 degrees is equal to 11 pi over 6. And 360 degrees is still equal to 0 radians, right? Because we've come back to where we started. Okay, so pause this and write everything down if you need to. And I will tell you that you will need to memorize all of these. You really cannot leave a trig class if you do not know these, and we're actually going to add on to this. So it's super important that, like, these are what I would consider really common angle measures that I could ask you to do calculations with without a calculator. So I want you just to kind of be aware this is what I would expect, and so this is something you're going to need to have memorized. I would highly recommend that just if you have time in your day, like you're waiting for a class to start or whatever, that you draw this out once a day until you are like dreaming about it. This is super, super important in a trig class. All right, so the last thing I want to talk about is I just want to go back to some of our trig functions, and now I want to just talk about how do you evaluate these trig functions now with radian measure. And you might want to refer back to this chart here. You might want to have this next to you just to make your life a little bit easier. So once you know this, like, you can do some of these radian measures much faster. So it's nice to have a certain set of them memorized. So let's talk about how to do this. So sine of 5 pi over 6. So the thing I know is that 5 pi over 6 is equal to 150 degrees. So you can look back at the circle to find that. So 5 pi over 6 is equal to 150 degrees. Okay. So then I want to evaluate sine of 150 degrees. And I want you to know 150 degrees, that falls into the Q2, right? That falls into the second quadrant. So one thing that we've discussed now is using kind of our reference angles. So I can take 180 degrees minus that 150 to get my reference angle. So 150 degrees is equal to sine of 30 degrees. So that's using reference angles. And now if I know something about sine of 30 degrees, we've also talked about this at length. So sine of 30 degrees is just going to be equal to 1/2 right here. So that will actually be the answer. So this is kind of a lot, but this is something you want to get very quick with, because you need to be able to do these without a calculator. This is the type of stuff that I would expect, and I think a lot of other classes would expect too. So let's do one of these together. Tangent of 3 pi over 4. So maybe pause and just figure out what is 3 pi over 4. So 3 pi over 4 is equal to 135 degrees. So what I really need to find then is the tangent of 135 degrees. So now, using our little cheat sheet here, I want you to determine what is our reference angle. So you can pause here if you want to figure that out. Okay, so 135 degrees falls into the second quadrant, so I take 180 minus that angle measure. So the thing is, in the second quadrant, tangent is negative. Remember, all students take calculus, so in the second quadrant, tangent's going to be negative. So I just take tangent of 45, and I just remember that it's going to be negative. Okay, so from here, now I think back to this chart that I've also said you definitely want to have memorized. So tangent of 45 degrees can be found right here, so it's just equal to 1. So that would be my answer. So now I want you to take your time to do these last two. Take as much time as you need, pause the video, do these two. When you think you're ready, hit play. Okay, so starting with the first one. So 5 pi over 3 is equal to 300 degrees. So I need to calculate the cosecant of 300 degrees, but I know that that's in the fourth quadrant, so I can take 360 minus 300. And this is going to be a negative function in that fourth quadrant. So I take negative cosecant of 60 degrees. And so then, referencing this little chart, I'm going to get 2 times the square root of 3 over 3. And so this will just be negative 2 times the square root of 3 over 3. Okay, and then for cosine, so negative 2 pi over 3. So this one's a little tricky for sure. So negative 2 pi over 3 is going to be equal to negative 120 degrees. And now you need to figure out what angle is coterminal with this. So what's like the positive version of this? So if I add 360 to this, I get 240. Okay, so what I really need to do is I need to determine cosine of 240 degrees. But, you know, with reference angles, what that means is I actually need to find, so this would put us in the third quadrant. And so this will be cosine of 60 degrees, and in the third quadrant, cosine is negative. So, whew, done all that work. So now, if I just look at cosine of 60 degrees, so that comes out to 1/2. So this just equals negative 1/2. So there's definitely a lot that goes into this particular lesson, and this is something that you've got to get pretty good at. If you found this helpful, leave a like or a comment, maybe share or subscribe. And if you have any questions, feel free to drop them in the comments. Otherwise, thanks for watching, guys. I'll catch you next time.